welcome everybody. Thanks for being here. I know we have a strong competition with everything else that's going on in the building. So again, thanks for coming. Again, my name is Adam. I will be kind of continuing the story of developer-facing tooling. This time it will revolve around the IDE that we're building, have been building, and will be building. But first things first, none of this would happen without the guys whose names are on the slide. This is mostly my team at Mistan, MoveCore team, with additional member, kind of honorary member here, which is Damir, who was responsible for some of the work that I'm going to present today. Well, I'll talk about some recent improvements in the IDE, in the Move IDE plugin itself. Then I'll tell you a little bit about the new piece of infra, which is tracing in the VM and outside of the VM, and then how it all leads to debugging. All right, so let's start with Move IDE. Hopefully some of you are using it. If you're not using it, maybe after this talk, you'll be encouraged to start using it. So first, a little bit of an overview. We have this VS Code plugin. It's available in VS Code Marketplace. This is the link. It's based on an architecture that's it's not extensible, but it's shareable between different editors. So while we mostly focus on the VS Code plugin, community maintains other editors that work very similarly to our VS Code plugin because they share the same backend based on the language server protocol. Some of these editors are mentioned here. It's Vim, it's Emacs, it's Zed. I think there may be others, but those I'm 100% aware of. We have made a lot of recent improvements. So say if you tried this plugin about a year ago, you'd probably be really disappointed in what it offered. I think now we're approaching a sort of a level of much more mature IDEs, though still there is a long way to go before we are really at the level of, say, Rust Analyzer or plugins for JavaScript with languages that have been around for years and years. But I wanted to highlight a few improvements, specifically focused on 3 features that were very strongly encouraged for us to develop by the community and very highly requested. So first one that has been around, it has been around now for, I would say, about 6 months. It's smart auto-completion. So very simple move code snippets, and basically you can see that when you have incomplete move code, say as dot, the IDE will suggest you either the field struct, which would fit after the dot, or a function in what we call a method syntax, rather than some random identifiers from the open editor, as it was the case before that feature was implemented. Similarly, if you start typing : you will get auto-completion for available either functions or types, depending on the context. But you get the gist of what's kind of happening here. It's just much smarter than it used to be. An extension of this is something that literally landed, I think, 3 weeks ago. It's auto imports. So if auto-completion is not quite finding the thing that you would like to insert in the place, there will be other suggestions available that come from different packages that are not yet imported in your file. So these are kind of marked by this use keyword, where by the sort of the string that's represents the auto-completion option. So once you do that, once you choose one of these options, not only the S will get kind of filled out to string, but also you'll have automatic import of the string from ASCII package, from the standard ASCII package in the module that you're developing. And finally, and that's a feature that Damir has implemented mostly, it's auto formatting, that also people were like really saying that they need it, and now they have it. So this is an example of a code snippet that kind of shows various things that you may see in other people's files. Of course, not your files, but other people's files. So like, you may have inconsistent branch block formatting. So, maybe curlies are on separate lines from like the beginning and end of the statement, or maybe on the same lines. So we'd like to unify that. You may have blank spaces in places where there shouldn't be any. You may have additional empty lines in places where there shouldn't be any. You may have lines that are very, very long, and all kind of messy. Obviously, I try to make it as messy as possible, but without a formatting, with one click, you'll just get it all cleaned up, right? So that's a nice feature, hopefully very useful for our developers. Let's switch gears and let's talk about execution tracing a little bit. So as I mentioned, it's a new piece of infra that recently has been introduced into the Move VM as a special VM execution mode. It's only available in local installations. It's never going to run on nodes, not even on full nodes, but let alone validators. What it does, it tracks Move code execution steps, right? So what it really means is that any time a VM kind of encounters an event while executing Move code, there is an event generated into the event stream that will be available as output for the person that's going to analyze it afterwards. And examples of events like execute an bytecode instruction, start a new function call, these are examples. And their output, again, as events, and the output as events in the JSON format. So each event is represented as a JSON object. The basic format is predefined, and that's what the VM is going to kind of offer you out of the box, but it's extensible. So you can create additional events that go outside of the VM execution, but you can also create your own tracer on top of it that will kind of either format or generate additional events that you will need for your, say, analytics tool. So this is an example of how the trace looks like. So you don't have to read all of this. It's just examples of you see instructions, right? So these are bytecode instructions. You see open frame, which is the start of a function call. You see effects, which is, for example, reading, writing to local variables, right? So just to give you an idea of what the trace looks like, right? What is generated, what comes out of the VM when you execute Move code. When I talked about extensibility, what we have in mind specifically right now is we would like to not only trace execution of Move calls inside of the VM, but we would like to trace execution of the entire PTBs. And unfortunately, Move VM is not aware of PTBs. So how do we do that? We're building a new developer-facing tool, which we call a replay tool. Actually, it's a second incarnation of a replay tool, but the previous one was mostly used internally. This one is meant to be used by developers. The idea is that given a transaction digest, you'll be able to replay locally any transaction executed on chain ever, right? So for example, if you encounter a problem, there is a bug, your transaction failed, you'll be able to replay it locally and in the future, generate traces out of the entire transaction, including all the PTB steps, including native steps, including all the function calls, and so on. And then you'll be able to debug it, because that's why you should care about all this, about this piece of infra, because it leads to debugging. And this is what we're also building. This is the first part of this talk was a little bit about what we already did. This is a little bit about what we're doing and will be doing in the near future. But the extension that I'm kind of showing here already exists. So we have a trace debugging extension. It's published in VS Code Marketplace. It goes way beyond the previous debugging steps that you were probably taking when debugging Sui transactions, which is staring at your code and maybe using some debug print statements and such. And if you ever used a kind of VS Code plugin with debugging capabilities, you'll be feeling right at home. It uses the same familiar interface. It's implemented such that it will work with our VS Code plugin, but it will also work with all these other editors, because again, the protocol that it uses is designed to work with different editors. And it's already available. You can download it and you can use it to debug your unit tests. And in the near future, you'll also be able to use it with the replay tool to debug the entire transactions, on-chain transactions. And I do have a preview of how this will look like. This is, again, not something that's not yet quite available, but it's a prototype that shows you kind of what it's going to look like in the near future. So let's start with just looking at one of the explorers. There is, let me maybe stop it for just a second. There's a PTB, consists of 2 function calls. It's a digest of this PTB. So what you'll be able to do is you'll be able to grab it. On the command line, you'll be able to use the replay tool, pass it the digest, press enter. It'll take a little while, but you'll be able to re-execute the transaction locally. I'm just showing the directory where it is, so that on the next step, you will see that I'm actually looking inside of that directory to look for the trace that was generated by this command. And this trace is available with all the metadata that represents the transaction that was also downloaded during that execution. So all the packages, all the objects, input objects, everything that you need to kind of re-execute this or retrace the execution of this transaction locally. Okay. So that's what we're doing. We're going to this directory, finding the trace file. This is a little bit more complicated trace file, as you will see. Let's not go back, but it represents the two functions. They're kind of cut off at the right end, but there is a retire bonding curve function and there's destroys area function. You'll notice that one of them is from some user package, the other one is from Sui standard library, right? So this is how the debugging will look like. So you have this overview, you have two functions, you can step into a function. You may be surprised by seeing kind of weird code that's not really move code, right? But that's unfortunately what happens when you download something from the chain, right? You don't really have source code readily available. So the default kind of mode of debugging in this environment is to debug through the disassembled bytecode, which is exactly what you're seeing. But you still have like the values of variables, like compound values, of structs and enums and vectors and everything. You can, go through the stack, execution stack of this PTB. You can obviously restart, and I am going to go back a little bit just to show you that, again, as I mentioned, one of the functions is from the standard package. So even in this prototype, if you know the source for your packages, or at least for one of the packages, you can use this information. You can kind of look for it wherever it is on your disk. In my case, it's my local copy of Sui repository, and you can copy it to a special directory in this kind of replay generated trace directory. And then when you step and you try to debug, I'm trying to in here step through between the different functions. Now you have source available, right? So it's kind of all by hand at this point, very much so, but thanks to the mover infra that Manos was talking about, we can easily automate it. So if we have a reverse mapping from the object package to the source code, we can make the tool download it for you automatically, and you'll be able to step through and put breakpoints. Everything works as it should in the actual source code rather than bytecode. So again, this is just a preview, but as you can see already, even here we can kind of debug through the source code for transactions that we downloaded or like replayed from chain. Okay, so that was the demo. I'm pretty excited about it. Hopefully you guys are also, and I think this is going to be a very useful piece of tooling. Hopefully your code has as few bugs as possible, but we all know that it does happen. So that's there's one more slide of basically what's coming. So there will be more IDE features. We are kind of at the good point at this point, but again, there's a long tail of little things, little or smaller, or little or larger things that we're still working on. Tracing is going to evolve as well. At this point, traces are pretty big because there's no clever encoding or anything. So delta encoding is coming soon. At this point, like all values are just represented as they are. So even if you have huge structs and everything, they'll be kind of present multiple times in your trace file. But that can be obviously optimized, and it's going to happen soon. We have some internal tooling that would like to rewrite you to use this common infra rather than they're doing things separately at this point, and they're based on different pieces of technology. And for debugging, we need to complete the implementation of both the replay tool and of the trace debugger to support all the PTB commands and everything. But ultimate goal is even further than that. The ultimate goal is that we would like to have this virtuous cycle of debugging cycle, so that you see a bug on chain in a transaction, you can replay that transaction, you can modify locally whatever you think is going to fix that bug, replay it again with the fix, and only after everything already works, kind of push to the chain and be kind of happy developer again. So that's our ultimate goal. I think I'm a little past time, but that's a good thing because I'm actually on the last slide where I wanted to thank you for coming and for listening to me.